So the very last type of reaction that we're going to be looking at is called a precipitation reaction, and this is actually just a double replacement reaction. And we'll look at one other type of double replacement reaction, which is acid-base reactions. So a precipitate in a precipitation reaction is an insoluble solid that is formed by the reaction. Okay, so let's see how that insoluble solid is actually formed. So we're going to be using our solubility rules again, just like what we did in the single replacement section, just as extra review for you. So in this example, you've got two different compounds, and they're going to form two new compounds. Specifically, I'm first going to write out the molecular equation to help you to see what's going on. So I've got copper with a 2+ charge. Chlorine has a -1 charge, so the formula for this would be CuCl2, and it's going to react with sodium sulfide. Well, sodium has a +1 charge, sulfur has a -2 charge, so it would be Na2S. And so what happens in a double replacement reaction is that you just exchange partners. So Cu is going to form, copper is going to form a compound with sulfur, and sodium with chlorine. I call it innies and outies. So copper has a 2+ charge, sulfur has a 2- charge, so I'm already crossed my charges. Na has a +1 charge, Cl has a -1 charge, so this would just be NaCl. And the last thing you need to do is balance. I'm going to put a 2 there, and now I'm balanced. The next thing that you need to do is you need to break apart into ions anything that is soluble. So if you look at chlorides, all chlorides at your solubility guideline, it tells you that they are soluble except for silver, mercury, or lead. Well, this is not silver, mercury, or lead, so I know this is going to be soluble, so it's going to be copper with a 2+ charge. Then I'm going to have 2 chloride ions, so 2 Cl- plus 2 sodium ions, and I know that's soluble because sulfide ions are insoluble except when they're with alkali metals, which is all group 1 metals. So this is going to be soluble, plus sulfur with a 2- charge. Okay. Then I look at copper sulfide. Well, all sulfides are insoluble, meaning they're going to stay together unless it's with ammonium, alkali metals, calcium, strontium, or barium. So this is going to stay together, so Cus. And then sodium chloride is soluble because you've got an alkali metal, which is always going to be soluble, so Na+, and 2 chloride ions. And then what you need to do, just like what we did before, anything that stays identical, you are going to get rid of. So notice copper does not stay identical. It actually forms a compound with sulfide, but the chlorine stay the same, the sodium stay the same, and so what I'm left with for my net ionic equation is copper plus sulfide ion, which produces copper sulfide. So keep in mind that your net ionic equation, what it does is it shows you the ions that are involved directly in the reaction. Okay? The ions that are not directly involved, the ones that you cancel out, those are called your spectator ions. Because while they're dissolved in the solution, they don't actually play a direct role in the reaction itself.